All right. So now we're working on homework on page 119. Um, I don't know. To start looking at this, it seems like we're doing kind of the same thing, where we're just looking at some overlapping triangles that are similar or whatever, but notice the big difference is it doesn't say that these triangles are similar. It instead says determine whether they're similar or not. And if they are, state what postulate or theorem you used, um, and write a similarity statement. So the postulate or theorem thing, that's our little shortcuts. We had angle, angle, similarity. That was a postulate, by the way. Then we had side, 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 similarity. That was a theorem. Then we had side, angle, side, similarity. That was a theorem. So when they say postulate or theorem, or if they say triangle, similarity, criteria, or if they say, what shortcut to triangle similarity did you use or whatever, then it's going to be one of these three things. And of course, the similarity statement is when you finally actually name the figures. Like triangle ABC is similar to triangle XYZ. That's your similarity statement. So let's get in here and see. It's asking me, are they similar? And well, I don't know. Honestly, I've got two different ways I could attack this problem. One way is by side, 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 because I have all the side measurements. So I've got this little triangle whose dimensions are 15 here, 18 here, and 16.5 here. And I've also got this bigger triangle whose dimensions are. If I take the total side length, it's 20. The total side length is 22. And then here the total length is, of course, 24. So if I want to do this problem by side, 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 then I just actually grab every single pair of sides. The 15 would correspond to the 20, the 18 to the 24, the 16.5 to the 22. So if I can divide all three of those and get the same answer every time, then the sides are proportional and then the triangles would be similar. So 15 divided by 20, factor out a 5, and you get 3 over 4, or 0.75. So if you do that again with the 18 and the 24, you can divide those numbers by 6. 18 over 6 is 3, 24 over 6 is 4. And then honestly you could stop right there. We can see that the orange ratio is 3 to 4, the green ratio is 3 to 4. That proves it if they have the same fraction. Or you can go out a little further. You can find the decimal. And then it's really obvious that we're getting the same decimal. So okay, these guys were equal. We got to test the purple now. So 16.5 over 22. Suddenly I can't do it in my head anymore, so we'll bring back our handy dandy calculator. And we'll ask it what it thinks 16.5 times 22 is. I meant to say 16.5 divided by 22. And it's 0.75. So that means, are we similar? Yes. If we're similar, then what's the postulate or theorem? Well, we used side, side, side because we literally showed that the orange sides, the green, and the purples are all equal to the same ratio, meaning they're all proportional. That's literally a side, and a side. So this should be side, side, side. Then we got to write their names. So the small triangle, I don't know, I'll say GHJ. Then GHJ is similar to FHK. That looks like I wrote FAK. But if you guys are listening and paying attention at all, then you know it's FHK. That's it. That's how this works. I should mention that if you wanted to do this another way, you could point out how angle H is congruent to itself. Then you could ignore the 18 and the 24. You could take this out of your work. And instead of using that to get side, 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 you could say that angle H is congruent to angle H. And you could justify that either by saying it's a shared angle, or you could use reflexive property. And that would work too. Here you would be saying, yes, they're similar. Now, based on your work, if you showed the angles, it would be by side, angle side instead. That's all. All right, so this one. Here you can probably tell that we have to use side, angle, side. We don't have any other choice. So blow that up about as big as I can. Oh, I left this calculator on the whole time. I'm sorry if that got in the way. Turn that off. Let's go back. Was that in the way of some of my work? Yeah, maybe it was a little bit. Hopefully not. Oops, I also wrote some stuff that went behind my face. My bad. So this thing from a minute ago, we should write H is congruent to H by the reflexive property. That's what I was saying. Anyway, for this one, we have to use side, angle, side, because we clearly can't use side, because this side is missing and we don't know how to find it. This side is missing too and we don't know how to find it. So that means our only other plan is to point out that these two angles are congruent because they're vertical angles. Then we can pair off our sides. Now it's pretty tempting to pair the 4 with the 4 and the 2 with the 8, but that's not how this works, because we said you have to pair the smaller one, and between a 4 and an 8, 4 is smaller. With the other smaller one, between a 4 and a 2, it's the 2 that's smaller. So this is tricky, and I think it's not drawn to scale. No, it is drawn to scale. So what you should be noticing again is these triangles, they are reflecting onto each other instead of rotating. So the 4 and the 2 mapping onto each other makes sense. And the 8 and the 4 mapping onto each other makes sense, as long as we can recognize this as more of a reflectional symmetry than a rotational symmetry. I'm using the word symmetry very, very loosely, by the way, because obviously they'd only be symmetrical if the triangles were congruent. So I'm imagining sort of growing this triangle so that it's a true reflection and then pairing up the sides. But you can kind of still do that even when one of the figures is smaller than the other. At least I can. I hope you can too. But for sure, we would want to be noticing that actually it's the 4 that corresponds with the 2 and the 8 with the 4. And then we can see that we do have the same ratios because we would divide the 2 by the 4 and get 1/2. We'd divide the 4 by the 8. We'd get 1/2. Oh my lord. And then you should probably also mention that angle QMP is congruent to angle AMB by vertical angles theorem. I don't like that. I'm just going to put a 1 here and a 2 here, so I can more easily just say angle 1 is congruent to angle 2. And we can abbreviate that it's by the vertical angles theorem, or because vertical angles are congruent. Anyway, for these triangles, are they similar? I'm screaming yes. What's the proof? The proof is by side, angle, side. Similarity, and I've shown my work to show that the sides are proportional. I've shown my work to address that the angles are congruent because they're vertical angles. Now I can name them. The first one I'm going to let it be, I don't know, PQM. Now again, PQM, if we're reflected, should be congruent to BAM in that order. And that's it for this one. Moving on. All right, my dog's gone. That's okay. Let's do this problem because this one is very easy. You'll notice that A and R are given to be congruent angles, and I assume you'll notice that these two angles are vertical angles. So we're done because we can say that this angle is congruent to this angle. So again, if you had to really formally prove this, you'd specifically state angle A is congruent to angle R. You would justify that that is given, and then you would point out either that AXB is congruent to RXQ, or just number them. I still am a fan of numbering. So then we can just say angle 1 is congruent to angle 2. And that is by the vertical angles theorem. And then you're done. Are they similar? You'll say yes. What postulate or theorem are we using? We're using the angle-angle similarity postulate. And then to name them, I'm going to go, I guess, AXB. And then A corresponds with R since they're labeled as congruent. And then we know that X corresponds with X, so X will go in the middle. So RXQ. And then we're done with that one. For 4, so 4 is a bit of a tricky one. Make it as big as I can. Looking at it, we can certainly pair off our corresponding sides and everything. 4 is smaller than 6 and 12 is smaller than 18, so those must correspond. 6 must correspond with 18. We can see pretty quickly that 4 times 3 will make 12, 6 times 3 will make 18, so we are proportional. We've got that ratio. But we don't have the other sides, so we can't use side, side, side. That's out. And I don't see any angles marked as congruent. Now again, I can find that these angles are congruent by vertical angles theorem, but I can't get a second, so angle's out. The only option left is side, angle, side, and that's not what we have, because side, angle, side has to be the angles that are between the sides you're using. So we would have to have angle B congruent to angle E. We do not have a way to prove that. So we have to say, are they similar? We can't know. The answer isn't no, they're not similar. The answer is we can't prove them similar. So are they similar? I'm going to say cannot be proven. Because maybe they are. We just don't have enough info. So if so, state the postulate. We're going to go not applicable. And for the similarity statement, this guy's not applicable again too. So that's it. Here the important thing to understand was just that what we had was an angle, a side, and a side in that order. An angle, side, side, just like before, that's not a thing. It doesn't work. So we got to move on. So here's 5. This is another easy one, if you know what you're doing. Because these little arrows, remember, are telling you that these lines are parallel. And as soon as those lines are parallel, you can treat this guy like a transversal. And then you know that this angle is congruent to this angle because there's corresponding angles. You could also say that this guy is congruent to this guy because they're corresponding angles. And you could even say that angle A is congruent to itself by reflexive property. So we can prove that all 3 pairs of angles are congruent, but you only ever need 2 pairs. So I think I'll stick with these ones. I'll label them 1 and 2. We'll say angle 1 is congruent to angle 2. That's going to be by the corresponding angles postulate. And you know what? Let's use the reflexive property. We'll say angle 3 is congruent to itself. So it's reflexive property. Or you could say shared angle. But that's it. That's good enough. That gives us our angle similarity, which means are they similar? Yes. Which means we can name them. The first one, ABE, I guess. And so then the bigger one would be ACD. That's it. And I think this might be the last one. And I'm getting strong side, side, side vibes from this one because we've got all the sides. Although we have an angle too. So this could be side, 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 or side, angle, side again. But to match these up, I see a 20, which is the biggest. And over here I see a 24, which is the biggest. So they must go together. You also know they go together because they're both opposite from the right angle. Then I see 10, that's the smallest. And 12 is smaller than 18, so the 10 must go with the 12. Then you've got a 15 that must go with an 18. So again, you've got a choice. If you wanted to, you could just use the green and the blue sides and then take that 90-degree angle as your angle. And you could do it by side, angle, side. Or you can take the red, the blue, and the green and do side, side, side. I'm just going to do, I don't know, side, angle, side is easier, isn't it? So let's check the blues. 15 over 18. Those are both divisible by 3. And you get 5 over 6. Then if you take the greens, you get 10 over 12. Those are both divisible by 2, and you get 5 over 6. And then, of course, you can talk about these angles. It's okay to say angle P. You don't have to use 3 letters. So angle P is congruent to angle W. And we can just say given. If they're both marked as 90 degrees, then it's given that they're congruent. So that gives us side angle side similarity. So are we similar? Yes. So which triangles are similar? I don't know, PMX. Something's happening with my little stylus. That's better. P corresponds with W, so W first. M means we've gone through the green side. So go through the green and you'll go from W to L and then to A. And that's it. Oh, there's more. So there's a 7 and an 8. Then we'll be done. So for 7, it says find the value of x that would make these triangles similar. So again, we're not really sure that they're similar, but we can figure it out. And we've got options here. We can see that AB wants to correspond with DE. So that's the 4 with the 12. That means that's a scale factor of 3. So maybe a very easy way to do this problem would be to recognize that if this is 18, then the side that corresponds to it would have to be 3. 3? 6, right? Yeah, because our scale factor is 3. So 18 divided by 3 says that x minus 1 should be 6. So x is 7. I kind of solved it already. But again, you really aren't allowed to do it that way. But we could say again, if this is 8, then this expression has to be 8 times 3. So that expression has to be 24. So we've kind of got some ways to go after this problem. But again, the expectation is that you're setting up a proportion. So try to stick to that idea. Yeah, let's say this. You definitely don't want to do this. You don't want to grab the 8 and the 3 times x plus 1 and then grab the other one, the x minus 1 over 18. This is just going to get ugly if you have to do it, because you're going to have x times x, which will make an x squared, and things are going to get a little harder than they need to be. So just don't forget, you've got the pink sides, and they're much easier to work with than the others. So I'd strongly recommend against the green. The green is the more complicated expression. Just don't use it. So grab those pink sides. Now what are we doing? We're doing small over big, so we'll do 4 over 12. And then don't forget too, I haven't really been mentioning this, but you can always reduce these fractions to make the numbers even easier. 4 over 12 becomes 1 over 3. So we really just have to distribute the 1 and the 3, and that'll make the math even easier. So 1 times 18 is obviously 18. 3 times x minus 1. Remember, if there's parentheses around this, we're distributing in. You have to do that. So you get 3x minus 3. So you add 3. That brings us up to 21. You divide by 3, and there's the 7 that I mentioned before. And so again, if we were to plug the 7 in, 7 minus 1 is 6. 6 times 3 is 18, just like we hoped. Over here, if you plug in the 7, 7 plus 1 makes 8. You do that first. Then you multiply by 3 and you get 24. And so yeah, 8 times 3 is 24. So we know that 7 is the right answer, because it definitely makes all of our parts proportional. For number 8, I see 2 triangles again that really want to be pulled apart and relabeled. So let me make things bigger. I suggest that you pull out the larger triangle and you pull out the smaller triangle. The small triangle is pretty easy. I see the 9 and the 7. The bigger triangle is easy too, because they're actually giving you the measurement of the whole side. So that's 45. And this whole side is the expression 3x plus 2. So, okay, this is not hard. We'll write a proportion. We'll take the 9 and the 45. They go together. I'll go 45 over 9. I'll set that equal to the 7 and the 3x plus 2. Again, if the 45 is in the numerator, the 3x plus 2 needs to go into the numerator. and the 7 will go into the denominator. And again, if I can reduce, I probably should. These are both divisible by 9, so you just get 5 over 1. Now when you cross multiply, 5 times 7 is only 35. That's easy to do. 1 times 3x plus 2 is really easy. It just stays 3x plus 2. So I'll subtract 2. The 35 will drop down to 33. It equals 3x. We'll divide by 3 and we get 11. And that'll do it. So they said find the value of x that makes these triangles similar. Great, that value is 11. Again, if you want to double check, 3 times 11 is 33 plus 2 is 35. So is that ratio working? Seems to be. 9 times 5 makes 45, and 7 times 5 makes 35. So yeah, we're proportional. And therefore we're similar. And then that's it for that homework. Remember the next homework assignment on 122, you can skip that one. We said we're not doing that. Nothing like that will be on the quiz. There are proofs on the quiz, but they're informal proofs. They're proofs like the ones we did here, where we just sort of said, hey, these are congruent because of corresponding angles. These are congruent by reflexive. So we're similar for that reason. But there won't be any formal 2-column proofs. So for that reason, you may skip the 122 homework, okay? But I'll see you guys again for the homework on 124. I think that's what this is. Yeah, must be 124. It might be 126, I'm not sure. Anyway, I'll talk to you later.